3/4 divided by 2/5 means how many groups of 2/5 are in 3/4, which I could write as 2/5 goes into 3/4 how many times? I'm going to draw a picture of that. So I'm going to use my square cake fraction method. So here's my hole for 2/5. I want to draw a matching hole. 3/4, close enough. Draw the long division box around that. My 2/5, okay, fifths. Let's see, a quarter would be about there. I think a fifth's about that big. Not too bad, a little smaller, that big. That's not bad. All right, so I want 2 of those fifths. This one. This one. And when I have different denominators, I like to draw the other denominator the other direction. So here I'll cut the 4ths this way. So 4ths I like to cut in half again. Not too bad. And I have 3 of those. See you, Gary. See you later. 1, 2, 3. Janky there. All right, so I can clearly see there's at least one of this blue inside of there. Now, since these pieces aren't the same size, I need to cut each like the other because fractions are equal parts of a whole, so I should make them equal. So I got to cut these 4ths into 5ths. So let's go down here. I think that's about a 5th. And then I want to cut 5ths into 4ths. All right, that should be reasonable. All right, so there's my best artistic rendering today. Now, what I've done basically here is said, well, let's just rewrite 2/5 as 2, 4, 6, 8 20ths. And we're rewriting 3/4 as what, 5, 10, 15 20ths. Now I want to know how many times 8 20ths goes into 15 20ths. And there's 2 ways to think about that. One way is to just look for groups of 8 up here. So 1, 2, 3, 4, 5, 6, 7, 8. So here would be a group of 8. Is there another group of 8? 1, 2, 3, 4, 5, 6, 7. No, not quite. So I found there's one group of 8 in there. And then 7 out of the 8 pieces I hoped for extra. So my claim based on this picture is that 2/5 goes into 3/4, 7 and 1/8, 1 and 7/8 time. The other way to think about this is I'm looking for groups of 8 in 15. Well, that's just 15/8. How many times does 8 go into 15? It goes in 1 with 7 remaining out of the 8 I was looking for. Now, funky thing about that is if I go back up here and rewrite the 3/4 as 15 20ths divided by the 2/5 as 8 20ths, once I find that common denominator, I don't need it anymore, and the answer is right there. The answer is 15/8. That answer supports what I call the arrow method, where the second fraction, its numerator and denominator get flipped. So that 2 gets multiplied by the 4 down here to give me an 8. And the 5 gets multiplied by the 3 up here to give me a 15. And there's my 15/8. So I've got a model here showing the groups in. Why should the answer be 1 and 7/8? Well, because that's how many groups of 2/5 live in 3/4. Once we find a common denominator, it just is what it is. That leads to an algorithm that says you could find a common denominator, adjust the numerators, then throw the denominators out. You're done with them, and there's your answer. The arrow algorithm is another nice way. And a third algorithm that most people are familiar with is that when you divide fractions, you should multiply by the flip or the reciprocal of the other fraction. And there's my 15/8 that way too. So this right here is my model. Why should the answer be that way? And these are three different algorithms here that give us an answer without an explanation. Just do what I say, that's the answer.